Hello, my name is Karl and I am a physicist in St Vincent's Private Hospital in Dublin. Today I will briefly talk about the Align RT system and how it works, describe vendor-specific QA and calibrations, and I will also outline some specific QA we perform for stereotactic and why it is important when using the system clinically. I would like to thank Dr. KarlJordan and Chen for the discussion and direction around some of the data that I will present today. Our department is a small department with 2 elective Versa HD linear accelerators. We have a dedicated GE Discovery CT scanner with Gate CT for 4D CT acquisition, and we use Monaco and Mosaic for treatment planning and plan delivery. We are a tattoo-less centre, meaning we rely on Align RT for initial setup for all treatment sites. Each Linac bunker is fitted with 3 cameras or pods, one at the foot of the couch and one to the left and right of the patient. Each pod is identical with a projector in the centre of the pod that will produce an optical spectacle pattern and 2 image sensors that will detect the reflected pattern for 3D reconstruction of the patient's surface. The white LED will illuminate the system during calibration and QA. Each pod will visualize the patient's surface from a different point of view, as seen in the images. The final reconstruction is a summation of these 3 images. Utilizing 3 pods will aid in a more accurate setup, as we can see more of the patient's surface, and it will also help to compensate for any pod obstruction as the gantry rotates during imaging and treatment delivery. The optical pattern that is projected onto the patient's surface can be seen on the left, and this will use approximately 20,000 points for accurate alignment of the patient. The system will focus on a defined region of interest, and although this can be the entire surface visualized by the cameras, it is generally a portion of this area. An example can be seen on the right, which is a typical ROI used during SRS. The ROI is drawn around the isocenter or region we wish to track, and we'll use this portion for positioning and monitoring during treatment. The software will perform a nearest point match of the 2 surfaces, and the registration will provide the offsets or delta values. Multiple regions of interest can be used for the same setup also. For example, in a bilateral head and neck, when you want to position each shoulder independent of one another, and then you can switch to another region of interest for final positioning and monitoring during treatment. In terms of what QA is required on Align RT, vendor specified QA includes daily QA and monthly calibration. The QA is performed using this calibration plate, which has a series of points evenly spaced on the plate. Daily QA is performed by setting the plate up on the treatment couch and aligning the plate to a surrogate of the treatment isocenter, such as the cross wires in ODI or in-room lasers. The orientation of the board will be checked and the pod position relative to the isocenter will be assessed to ensure the current monthly calibration is still valid. The default setting in Align RT for daily QA is 1 mm. Monthly QA performs 2 functions. It will define the isocenter position within Align RT, from which all patient moves are calculated, and it will also determine optical parameters within the camera pods. The position and orientation of each camera is computed relative to the center of the calibration plate and the orientation of the plate. This is why it is important to place the plate as accurately as possible to the isocenter. For a more accurate calibration of the Align RT isocenter position, which is required for stereotactic, the MV calibration cube can be used. This will fine-tune the optical isocenter to be coincident with the radiation isocenter using a Winston-Lutz test. The cube has 5 ceramic spheres with 4 spheres positioned asymmetrically around the center, allowing for radiographic imaging. The surface of the cube is also visible to the Align RT cameras. The cube can be used for multiple QA tests that can satisfy criteria currently described in TG 142 and 147. To perform an MV isocenter calibration, the cube surface is positioned to the optical isocenter by zeroing out all the delta values. in the MV calibration software. Using the internal spheres, 4 radiographic images are required at the cardinal gantry angles, and using the software within AlignRT, offsets between the current optical isocenter and the MV isocenter are computed and can be applied. The 3 graphs above show the results of the isocenter coincidence QA performed over a number of weeks on one of our Linacs. Only on one occasion was the AlignRT system recalibrated, as it was outside of our departmental tolerance of 0.5mm. We also performed a Winston-Lutz test using a 2x2cm MLC defined field and analysed the images using other commercial software to determine the average radiation isocenter position in space and how the radiation isocenter moved as the gantry rotated. Aside from the more common benefits of AlignRT, such as the ability to remove permanent reference marks, one of the most beneficial aspects of AlignRT is the ability to monitor a patient's position when the couch is rotated off zero couch angle. In a perfect world, the couch would rotate perfectly around the radiation isocenter, but in reality there will be limitations preventing this. During stereotactic, the CBCT is the gold standard for patient setup. The CBCT will allow us to localise the planned treatment isocenter at the radiation isocenter during setup. The CBCT will tell us where we are currently at couch 0. But the CBCT is only valid at couch 0, and when we rotate the treatment couch, anything on the couch will shift off the radiation isocenter. AlignRT will help us in maintaining this position by monitoring the patient as the couch is rotated. Analysis of the couch walkout by comparing measurements with Winston-Lutz and AlignRT will allow us to make an informed decision when the couch is rotated during stereotactic and if the delta values are due to couch walkout or patient movement. The following graph shows the couch walkout of one treatment couch measured using a Winston-Lutz test, shown with the red squares, and using the AlignRT MV cube. For one of these treatment machines, the couch walkout values agree to within 0.3mm. So we have determined AlignRT can be used here with no non-coplanar beam arrangements and accurately track patient position. The clinical workflow for stereotactic within our department with the addition of AlignRT is pretty straightforward. The patient is positioned with AlignRT. As mentioned, multiple ROIs can be used to correct for postural alignment. When the delta values are zeroed or within tolerance, for example 1mm, 1 degree, a CBCT scan is acquired. The patient's position would be corrected by implementing the moves from the CBCT registration. After the moves are implemented, a new reference capture is acquired with AlignRT, which tells AlignRT that this is my new treatment position. All delta values will now or should read 0. Treatment delivery can begin, and if the patient moves outside of tolerance, the beam will terminate and the treatment position can be corrected or assessed. So how would this look clinically? A typical ROI for SRS is shown, being careful not to include any areas of the thermoplastic mask and include areas that would be representative of the patient's position, such as the forehead and nose. After the position is corrected based on the CBCT registration, a new reference is acquired and the delta values will zero out. If the patient moves, AlignRT will show this by updating the delta values as seen on the left hand side. When we load a field with a couch rotation, the surface within AlignRT is rotated. We can then rotate the treatment couch to position the patient at that particular couch angle. It is important to remember that the current delta values represent the patient position and the couch walkout of your treatment couch. These delta values are within tolerance and we can now begin treatment as shown on the right hand side. If the patient does move or the delta values are out of tolerance, we can then return the couch to couch 0, assess the delta values to check whether the patient has moved, or if the delta values gone out of tolerance are due to couch walkout or some pod occlusion. We can acquire a new CBCT to verify the patient's position, acquire a new line RT reference in this new treatment position, and continue to monitor the patient and deliver the rest of the treatment. To summarise, the calibration plate is used for daily QA and monthly calibration to assess and recalibrate the Align RT isocenter. The calibration cube can be used to verify the isocenter coincidence across multiple systems. We can use the cube to verify the accuracy of the couch rotational isocenter, and we can also use the cube to recalibrate the Align RT isocenter to ensure it is coincident with the MV isocenter. For patient localization, we can use Align RT to position the patient and verify this position using CBCT, which is the gold standard. During treatment delivery, we want to know, can we remain in the treatment position? Align RT will provide a form of non-contact immobilization, monitoring the patient during treatment, and if the patient moves out of a defined tolerance, the beam will be held. SRS with Align RT requires a good delineation of the ROI to ensure the system can track the surface accurately. We need to be sure the MV isocenter and optical isocenter are coincident, and when performing couch rotations during treatment, the couch walkout has been established using a Winston-Lutz test and Align RT. Thank you for your time. I'd like to thank Vision RT for the opportunity to speak today. I'll be happy to answer any questions you may have.